Hello and welcome to another video of Learn with Vishwan Vasila. Today we'll be learning about cryogenic sampling. The crow sampling technique is designed for pre-concentrated chemical or called cold trapping. So cryogenic is under minus 180 degrees Celsius, I suppose. So everything that is cold or liquid cold, they are stored in cryogenic tanks. So coolant frequently used for the trap are ice water, solid carbon dioxide, isopropyl alcohol, liquid oxygen, liquid nitrogen, and liquid helium. Other equipments for this kind of sampling are pumps, sequential sampler, and operating power. Material specifications should be obtained from manufacturer for purchaser consideration. The cryogenic. The cryogenic year sampling method is a way by use of the principle of cryogenic plumbing. A cryogenic plumb which uses a cryogenic coolant can continue to evacuate because most major components in the atmosphere are condensed to solid immediately. Liquid helium or liquid neon is candidates for the coolant in many cases. A sampling system using the cryogenic pump does not require any mechanical pumping system nor power. It is suitable for an onboard sampler. The sample amount is, generally speaking, not limited by the sampling altitude. When the volume of sample cylinder is the same as that of the graph sampling, the sample amount of 1000 times can be achieved easily by this method, even more 30 km altitude. As liquid neon has larger latent heat than liquid helium, it can condense air more efficiently. Neon, hydrogen, and helium exist as gases at the boiling point of the liquid neon. Those gases are rare in the atmosphere, therefore they have no effects on concentration measurement. Liquid helium temperature is, on the other hand, less than that of liquid neon, and only hydrogen and helium exist as gases. The saturation vapor pressure of hydrogen at the boiling point of the liquid helium is merely 0.0001 Pascal. True liquid helium has less latent heat than liquid neon and is required as in amount to sample the same amount of air. Its heat capacity, mainly by sensible heat, can be utilized when heat exchange in the low temperature gas is made efficient. Helium in the atmosphere cannot be condensed, but it has no effect on the concentration measurement of minor constituent because its amount decreases rapidly in proportion to the atmospheric pressure. Helium can be sampled and stored when other atmospheric components are inhaled into the cylinder and when it is prevented from back diffusion. While the coolant exists in the cryogenic sampling system, ambient air can be inhaled into the sample cylinder. As a result, much larger amount of air can be recovered from that by grabbing sampling explained above. So moreover, the sample cylinder may be smaller and the possibility of absorption or reaction on the inner surface be reduced dramatically. Should the sample amount be not controlled appropriately, the air in the cylinder may become very high to compromise the safety when the air warms up to room temperature. There are technical problems awaiting solution in addition to those for the grab sampling, including the high pressure and cryogenic technologies. Therefore, precaution of minor constitution research are the same as those of grab sampling. So figure 1.16 shows the detail of various coolant which can be used in a cold bath solution. The basic structure of cryo sampling is given in figure 1.8. Immediate inhaled bulb, and this is liquid helium which will keep it in liquid state, evacuated, and liquid helium. Nice. So we'll do this much today. Thank you so much for watching. Hope you are not bored. Thank you.